Ever wondered why the sky looks blue? It's a question that has fascinated people for centuries. It's one of those questions we all ask at some point, so let's dive into the science behind it. Get ready for a colorful adventure. Alright, let's start with sunlight. It's the key player in this beautiful phenomenon. Did you know that sunlight, or white light, is actually made up of all the colors of the rainbow? That's right, it's a full spectrum of colors. Yeah, it's like a party of colors traveling together. Imagine a parade where every color is represented, but not all colors travel the same way. They each have their own unique journey. When sunlight hits our atmosphere, it encounters tiny molecules and particles. These interactions are crucial. Now, these molecules and particles are much smaller than the wavelength of visible light. Think of them as tiny obstacles in the path of light. Here's where it gets interesting. The scattering of light. This scattering is what gives the sky its color. This phenomenon is called Rayleigh scattering, named after the scientist Lord Rayleigh who studied it. Rayleigh scattering happens more to shorter wavelengths of light. These shorter wavelengths are more easily scattered. And guess what? Blue light has a shorter wavelength than red, yellow, or green light. This makes blue light more prone to scattering. So, when sunlight passes through the atmosphere, the blue light gets scattered in all directions more than the other colors. Imagine this. It's like a grand display of blue light. You're in a big crowd and everyone's wearing different colors. Now picture this crowd from above. If you throw a bunch of blue confetti in the air, it spreads out and you see blue everywhere. It's a similar effect with blue light in the sky. That's kind of like what happens with blue light in the sky. It scatters everywhere, creating that beautiful blue hue we see. It scatters everywhere, making the sky look blue to our eyes. This scattering is what paints our sky blue. But wait, what about sunrise and sunset? Those times when the sky is ablaze with reds and oranges. Why do we see those beautiful reds and oranges instead of blue? Great question. Let's explore that. During sunrise and sunset, the sun is lower in the sky. This changes the way light travels through the atmosphere. The light has to pass through more of the Earth's atmosphere to reach us. This longer path affects the scattering process. This longer journey causes even more scattering of the shorter blue wavelengths. The blue light gets scattered out before it reaches us. By the time the light reaches us, most of the blue and green light has scattered out, leaving the reds and oranges to paint the sky. It's a stunning transformation. So, in a nutshell, we see a blue sky because of Rayleigh scattering. This scattering is what gives us those vibrant blue skies. The shorter blue wavelengths get scattered in all directions by the atmosphere, while the longer red wavelengths pass through more directly. This difference in scattering is key. Next time you look up and see that vast blue sky, remember the science behind it. It's a beautiful blend of light and atmosphere. You'll know it's all thanks to some fascinating science happening right above our heads. The sky is a canvas painted by light. Thanks for tuning in, curious minds. We hope you enjoyed this colorful journey. If you enjoyed this quick dive into science, don't forget to like, subscribe, and hit that notification bell. Stay curious. Don't forget to like, subscribe, and hit that notification bell. Keep exploring the wonders of our world. Keep wondering and keep exploring. Catch you later. Until next time, keep looking up and marveling at the sky.